All right, so this is part 2, 3.3 for Math 9. So in your handouts, let's take a look at subtraction word problem number 1. We talked about subtraction of rationals yesterday, last class. And one of the things you want to remember, one of the really important things, which I'll just remind you of here, when you subtract a negative, as in this case right here, when we subtract, in this case, a negative 4, right there. When you subtract a negative, it's the same as adding, right? Two negative signs make a plus, but they're right beside each other. Also, when you're subtracting, you can think of it as changing that subtraction to addition, and then you can add the opposite of whatever integer you're subtracting. So if you change this to plus, like I did here, and then add the opposite. So the opposite of negative 4 is positive 4. That's the same as adding. So however you'd like to think about that, that's totally up to you. But that's what we want to keep in mind when we when we do this stuff here. So the first word problem says the temperature in St. John's is 6.5 degrees. Okay, this is a positive 6.5 degrees. So if we have a thermometer here, let's say, then positive 6.5 would be about here, let's say. And this would be, let's say, 0. And in Corner Brook, it is 8 degrees colder. So in word problems, you're going to have to interpret the words as positive or negative signs, right? So that's kind of the trick. You see a 6.5, that's positive in this case. You see an 8 degrees, that is not a temperature, that's a change in temperature. And it is going down because it's getting colder. You see that? So this means a minus 8. That's what that means. What is the temperature in Corner Brook? So if you have 6.5 degrees Celsius, you need to subtract 8 from that, minus 8. So let's write our sentence. And when you do these word problems, remember a couple things. You certainly need to show your work by setting up a math statement, like an equation or something. Simplify it, show your steps to simplify. Show your answer and make sure that you have your answer with the proper units, okay? And make sure you circle your answer because you got all this work. I need to see your answer because some of you are like doing your work like this and it's upside down and it's all over and I don't know where the answer is and I need you to practice being a little bit more organized like that, okay? So show your work and then your answer, circle it. If it's a sentence for a word problem, good idea to have a sentence for a word problem. In high school, honestly, as long as you show all your work, give me the right answer with the proper units. I don't need a complete word sentence most of the time, but a word sentence would make sure that you have your answer stated and the units stated and everything like that, and everything is good. So a word sentence is still a great idea. So I'm going to start with 6.5 here, and I'm going to subtract 8. Okay. If you want to write 8.0, you can. Right? Doesn't really matter. But that's what we want to figure out here. So on our number line here, our thermometer, we go down 6.5 to 0. This is 6.5. And then I got to go down another 1.5 degrees to make 8. You see? Because 8 is 6.5, and 1.5. Is that right? So 6.5 plus 1 is 7.5, and then another half is 8. So in your head or with a number line or a thermometer, you could maybe figure out that this is negative 1.5, right? So the temperature and this 3 little dots, have you guys ever seen those before? Have you ever seen those 3 little dots like that before? That means therefore. So it's kind of a math, science, shorthand. So you can write the 3 little dots like this, like in a triangle shape. Therefore, the temperature in Corner Brook is negative 1.5 degrees Celsius. Okay. And again, I am okay if you just put negative 1.5 degrees Celsius as your answer as well. Okay. All right. Any questions about that? You do need to read carefully the word problem because, like I say, if you just look at this 8 degrees Celsius and 6.5, I know for a fact that some of you will just add that or just subtract them or just add them without even really thinking too hard about it. So please make sure that you understand what the words mean. Okay. All right, if there's no questions, let's go to the second one. So the second one says this: a piece of pipe is 146.3 centimeters long. A piece 13.7 centimeters is cut off. How long is the remaining piece? All right, so what does is cut off indicate to you? Yes, subtraction, of course, yes. So the pipe initially is 146.3 centimeters long. Now, should I write this as a positive number or a negative number, do you think? The 146? Yes, positive. Anything that's a length should be written as positive, okay, in a word problem. If you have a negative length, you need to look very carefully at that. You probably made some kind of mistake, because a length in a word problem should always be positive. Because you can have something that's this long, let's say, and then you can have something that's a little smaller. You can have something that's 0, units long, but you can't really have something that's negative 0 units long. You're kind of you're creating some negative, antimatter space there. You can't do that. So you can't have anything that's less than 0 units long, okay? So a negative on a length. A subtraction is fine, but a negative on a length, if you get that as an answer, you have to look very carefully at that. You probably did something wrong. Okay. A piece of pipe is 146.3. Oops. 6.3 centimeters long. And we're subtracting 13.7. So I'm going to write it like this. Okay, so I don't know if you guys need, again, yes, you can use your calculator, but I want to reinstill sort of this, how you can do this manually as well. So 3 minus 7, can't do that. What do you got to do? You got to borrow, right? So that's 13 minus 7 is 6. We'll drop that decimal place down there. Now I've got 5 minus 3 is 2. 4 minus 1 is 3. 1 minus 0 is 1. So how does that look? Does that look good to you? 132.6, does that make sense? 146 minus almost 14 is about 132. Yeah, I like that. So how long is the remaining piece? It is 132.6 centimeters long. Okay? And again, you can just write the number with proper units, with the proper sign and everything like that. Make sure you do that. Okay? How you guys feeling about this? Good? Yes? So? Good? Some nods. Okay. All right. Number three. So let's take a look at the last sort of word problem that we have here on our notes package. A person climbs 12 2/3 meters above the water to the top of a cliff. All right. So if you're visual people, and in math, you should, when you can, draw a picture or a diagram or a sketch of the situation. Might help you sort of understand what the question's asking for. I would strongly encourage that, even if you're not a visual type person. But so we have a cliff, okay, and it's above water, and it's exactly 12 2/3 meters above the water. Normally when we do operations with fractions, we like them in improper form, right? Not mixed. So why don't we just do that? What's 12 times 3? 36. Yeah, 36 plus 2, 38. Good, over 3. Awesome. So that's going to be our height above the water. He dives into the water and reaches negative 3 1/6 meters below the surface. So we're going down below the surface to this point, which from the surface of the water, which you could probably think about that as 0, couldn't you? Because this is a positive number up here. And then we're going down below the surface area. So like on a number line or a vertical line like that, you might think of the water as 0. So this is an improper fraction. Let's see, 3 times 6 is 18, plus 1 is 19. So this is negative 19 over 6. Okay, so what is the difference in these heights? So on my diagram, it's pretty easy for me to see now that I'm looking for this entire distance right here. Okay, now be careful how you write this. I don't mind if you look at your diagram and say, hey, I know what I need to do. I need to go 38 over 3, this length right here, and really I need to add this 19 over 6 length. I'm okay if you go right to here because of your diagram, because that's what you need to find, the difference from this height to this height, the total difference. As a subtraction or as a difference, this is what you would do. You would do 38 over 3 minus this distance, negative 19 over 6. So you'd find the difference between you. This is the large one, this is the small one. So take the large one minus the small one, and that's the difference. Now notice that these two are exactly the same because I'm subtracting a negative. Okay? Any questions about that? When you find a difference between any two numbers, take the large one minus the small one. That's the overall difference. Okay? So I need to get these two. I'll zoom in for you at the back. I need to get these two with a common denominator right here. So I'm going to multiply top and bottom by 2 here to get 6, right? So 38 times 2, well, that's 30 times 2 is 60. 8 times 2 is 16. So that's 76, right, over 6. Plus 19 over 6, and I'll just do the one operation here instead of both of them because they're the same now. So 76 and 19, I look at this and I say, well, what's 76 plus 20? Because that's pretty close to 19. That's going to be 96. 19 is 1 less than 20, so 96 would be 95. So 95 over 6. Oops. Oh, that's too bad. So I got 95 over 6. Now, can I... Oh. All right, let's try this one more time. 95 over 6. And so you can make this into a mixed fraction. Yeah, for sure. Do you know how to do that? Yeah. You guys know how to do that? I mean, your calculator could probably do that. You probably have a button, like a fraction button, where it can change from improper to mixed. But how would you do this if you didn't have that fancy button? Yeah.
You can divide 95 by 6 and then, like, the whole number, you can put the whole number and then
Yep.
the remainder over 6.
Right. So you divide 95 divided by 6 to get 15. So that means that 15 whole groups of 6 go into this, right? Okay. So we have 15. And then you have to figure out what this decimal really is, right? 0.83. So you could do 0.833333 times 6 to find out what number that is. Or you could do this. You could do 6 times 15 is 90. So what's left over from 90 to 95 is 5. So you could say 5 over 6. So 5/6 is left over. Yeah, that's good. And again, if you want to explore your calculator, you should have a button that changes from improper to mixed fractions. But now, this is a word problem, so I got to make sure that I have my units set out properly. So what's the difference here? What's the unit? Yeah, meters, right. So the difference is 15.56 meters. What's the difference? That's the difference right there. Okay? And again, another thing is to just circle one answer. So notice before I just erased those 3 things, notice how I had 3 circles here? So in my classes and in high school math, not a good idea to circle multiple things in your work, okay? You need to clearly indicate what your final answer is. So if you do something like this, and again, I'm teaching and highlighting things, so I'd do circles and arrows and stuff all over the place, but you should either erase those other circles if you do, and make sure you have just one, or clearly identify, you don't have to get too artistic, but clearly identify your answer so that I know you know what your final answer is. Okay? All right, let's do this final thing. There's 2 questions here, and you might get some questions like this, which requires you to think a little bit outside the box. Okay? No pun intended. Here's a box right here. We want to think inside this box, but in subtraction equations, sometimes if we have parts of an equation that's missing, we might have to either think about the opposite operation, or I don't know, there's multiple ways you could think about it. So let's take a look at A first, and let's talk about A. So if you're trying to fill in this equation, okay, determine the missing number in each equation. You have 2.5 of something, and you're subtracting some number to get 3.8. So what I noticed right away is that 3.8 is bigger than 2.5. So I have to somehow make this into an addition. So I know what does this answer inside here have to be? What's one characteristic of this answer?
A negative?
It does have to be a negative, yes, thank you. Yes. Now, I'll get you to put up your hand maybe to answer, because I know there's some other people that want to answer. I have a few quick people here, so you guys are always jumping in, which is great. But maybe just put up your hand. I want to call in some others too, because I want to know what other people are thinking as well. Okay, so some of you guys that are like, hiding in the corner. All right. So yes, it's gonna be a minus. Okay, or it's gonna be a minus a negative, and that will turn into a positive, right? So you got to think about this as 2.5 plus something will give us 3.8. Okay. So you could do trial and error or use your intuition here. You could also turn this into a subtraction. We just want to find the difference between 3.8 and 2.5. Okay? So what's the number here? Put up your hand if you think you know. I'll call on some different people. Yes?
Try to say answer.
Yeah.
1.3.
1.3?
Negative.
Okay, so negative. Okay, so you think 1.3 goes in here? All right, let's just test that out. 2.5. I know minus a negative should be a plus. Okay, does this statement look true to everyone? Yeah, 2 plus 1 is 3. 0.5 plus 0.3 is 0.8. We're good to go. Perfect. Thank you very much. All right. Now, the other way you could actually do that, if you didn't know what this 1.3 is in your head, you go, hey, 3.8 minus 2.5. I just need to find out what that is. Okay, so there's a 3 there, and there's a 1 there. 1.3. Easy. Okay, what about this one? Fractions. Oh, no, fractions. Whew. Tough one. Some number minus a negative 3 over 10 has to equal 2.5. So you could think about this as some number plus 3 over 10, right? Equals 2 over 5. Now, when you're solving for a missing piece like this, a couple things you want to think about. When you're adding fractions, you do have to have a common denominator, right? So you could say, okay, I'm going to think about what something over 10 might be here, because I need to add these two up. And then you also might want to think, hey, this is over 5, so I should really get this to be over 10 as well. So this is one way you could think about this. Something over 10 plus 3 over 10 would have to equal, what's this? 4 over 10. Now, is that an easy one to solve? What plus 3 equals 4? Yeah. Well, okay, so again, we're adding, we're not subtracting. I know this looks like a subtracting, but 7 here would be 7 plus 3. So we want to go something plus 3 equals 4. Yeah.
1 over 10.
Okay, 1 over 10. That's the correct answer. You're right. So 1 over 10 plus 3 over 10 is 4 over 10. So let's see. This plus came from this minus a negative. So right here is 1 over 10. Like it. Okay. So that's putting together all the things that we've learned in this lesson here about the double negatives here, subtracting a negative, and so on. Okay, any questions about that? No? No questions? You guys got it figured out? Okay. All right, make sure you have all the questions in your notes package finished up. I think I've pretty much gone over every one of them. So if you've been keeping up with the lesson here, you've kind of got everything in here. Here's the rest of your assignment. Please go ahead and work on that and finish that. And if you get done that in this class, let me know. I'll come and take a quick peek at them probably and let you know what you can work on here next.